Today we are going to make revision on chapter 2, which is chemical analysis. We are going to discuss different types of questions and the problems and to show their model answers. So let us start. Choose the correct answer. Solid salt plus dilute hydrochloric acid gives reddish brown fumes at the mouth of the tube. Is it nitrite, nitrite, nitrate, or sulfite? If you think about it, yes, it will be nitrite. Next point. Solid salt plus dilute hydrochloric acid gives gas turns paper wet with acidified potassium dichromate K2Cr2O7 by sulfuric acid from orange to green. Is it sulfite, sulfate, nitrate, nitrite? If you think about it, yes, it will be sulfite radical SO3 negative 2. Next point. Salt solution plus potassium permanganate solution acidified by sulfuric acid. Here decolorize the violet color of potassium permanganate, the radical which is nitrite or sulfite, sulfate or nitrate. If you think about the answer here, my dear student, yes, it will be nitrite. Next point. Solid salt plus dilute hydrochloric acid gives gas turns paper wet with lead acetate into black. This salt contains nitrite radical or carbonate radical or sulfite radical or sulfide radical. Yes, if you think about it, yes, it will be sulfide radicals. Next point. Salt solution plus magnesium sulfate solution produce white precipitate after heating. Is it sulfite or bicarbonate or carbonate or nitrite? If you think about it, yes, it will be bicarbonate as white precipitate after heating. Next point. Solid salt plus dilute hydrochloric acid gives yellow precipitate of suspended sulfur. Is it sulfide, sulfate, thiosulfate, or sulfite radicals? If you think about it, yes, it will be thiosulfate radical. Next point. Salt solution plus magnesium sulfate solution produces white precipitate on cold. What is this radical? Is it sulfite or carbonate or bicarbonate or nitrite? Here the white precipitate on cold, so it will be, yes, carbonate radical CO3 negative 2. Next point. Salt solution plus silver nitrate solution produce white precipitate turns black by heating. Is it sulfide? Is it sulfite? Is it thiosulfate or nitrite? If you think about it, yes, it will be sulfite radical. Next point. Salt solution plus silver nitrate solution produces black precipitate. What is the radical here? Is it sulfite, thiosulfate radical, or nitrite, or sulfide? If you think about this type of acidic radical, yes, it will be sulfide. Next point. The salt solution plus iodine solution, it removes the brown color of the iodine. What is the type of the acidic radical here? Is it sulfite or sulfide or thiosulfate or nitrite. If you think about it, yes, it will be thiosulfate radical. Next point. Here, salt solution plus silver nitrate solution produces yellow precipitate that insoluble in concentrated ammonia solution. This radical, is it iodide or nitrate or phosphate or bromide? Here, if you think about it, that yellow precipitate insoluble, yes, it will be iodide that insoluble in ammonia solution. Next point. Solid salt plus concentrated sulfuric acid gives orange red fumes that turns paper wet by starch into yellow. Is this radical chloride, iodide, bromide, nitrate? If you think about it, yes, it will be here bromide. Next point. Solid salt plus concentrated sulfuric acid gives gas that forms white fumes with paper wetted with ammonia solution. Is this radical bromide, chloride, iodide, nitrate? If you think about it, yes, the answer it will be chloride, as forming white fumes of ammonium chloride. Next point. Solid salt plus concentrated sulfuric acid gives violet fumes that turns paper wet with starch, wet by starch, into blue. What is the radical here? Is it chloride, bromide, nitrate, iodide? If you think about it, yes, the answer it will be iodide. Next point. Solid salt plus hot concentrated sulfuric acid gives brown fumes that increase by adding excess copper turning. What is the acidic radical here? Is it nitrate, chloride, bromide, iodide? If you think about it, yes, the answer it will be nitrate radical. Next point. Salt solution plus silver nitrate solution produces white precipitate turns violet in sunlight. Is the acidic radical iodide or nitrate or bromide or chloride? If you think about it, yes, it will be chloride. Next point. Salt solution plus silver nitrate solution produces white yellow precipitate. What is the acidic radical here? Is it bromide or nitrate or chloride or iodide? If you think about it, yes, the answer it will be bromide. Next point. Salt solution plus barium chloride solution produces white precipitate insoluble in dilute hydrochloric acid. Is it phosphate or sulfate or nitrate or nitrite? If you think about this radical, it will be, yes, the answer it will be sulfate, as it is insoluble in dilute hydrochloric acid. Next point. Salt solution plus lead to acetate solution produce white precipitate. Is it phosphate, nitrate, sulfide, sulfate? If you think about it, yes, the answer it will be sulfate. Confirmatory test for sulfate radical. Next point. Salt solution plus barium chloride solution produces white precipitate soluble in acids. What is it? Phosphate, sulfate, nitrate, nitrite? Yes, if you think about it, that soluble in dilute acids, yes, it will be phosphate radical. Next point. Salt solution plus silver nitrate solution produce yellow precipitate which is soluble in concentrated ammonia solution. Here it is soluble. If you think about the radical, is it iodide or sulfate or chloride or phosphate? If you think about it, yes, it will be phosphate radical. Next point. Salt solution plus silver nitrate solution produces yellow precipitate which is insoluble in concentrated ammonia solution. Insoluble in ammonia solution. So, is it bromide or phosphate or chloride or iodide? If you think about it, yes, the answer it will be iodide. Next point. Salt solution plus sodium hydroxide solution produces reddish brown precipitate. Here it is test for basic radicals. Is it calcium, iron 3, aluminium, or iron 2? If you think about it, yes, it will be iron 3 cation. Next point. Salt solution plus sodium hydroxide solution produces white-green precipitate. Is it iron 2, aluminium, calcium, iron 3? If you think about it, yes, it will be iron 2 cation. Next point. Salt solution plus dilute hydrochloric acid and hydrogen sulfide gas, giving black precipitate. What is the cation here? Is it calcium, iron 2, iron 3, or copper? If you think about the answer here, my dear student, yes, the answer it will be copper. Yes. Next point. Salt solution plus sodium hydroxide solution produce white gelatinous precipitate. What is the cation here? Is it calcium, iron 2, iron 3, or aluminum? Yes, if you think about it, yes, it will be aluminum cation. Next point. Salt solution plus ammonium hydroxide solution produces reddish brown precipitate. What is the cation here? Is it calcium or iron 3 or aluminium or iron 2? Yes, if you think about it, yes, it will be iron 3. Next one. Salt solution plus ammonium hydroxide solution produces white-green precipitate. What is the cation here? Iron 2 or aluminium or calcium or iron 3? If you think about it, yes, it will be iron 2 cation. Next point. Salt solution plus ammonium hydroxide solution produces white gelatinous precipitate. What is the cation here? Is it calcium, iron 2, iron 3, or aluminium? If you think about it, yes, it will be aluminium cation. Next one. Salt solution plus ammonium carbonate solution produces white precipitate. What is the cation here? Is it copper, iron 2, iron 3, or calcium? If you think about it, yes, the answer it will be calcium. Next point. The salt solution plus dilute sulfuric acid produces white precipitate. Is it copper, iron 2, iron 3, calcium? If you think about the cation here, yes, the answer it will be calcium. Next point. Calcium gives what color of flame in the dry test? Pale violet flame, yellow flame, blue flame, or brick red flame? If you think about it, yes, it will be brick red flame. Next point, when adding 25 milliliter of hydrochloric acid, its concentration 1 molar, and added to 25 milliliter of sodium hydroxide solution, its concentration is unknown, containing drops of bromocymol blue. At the end of the titration, the solution color, it changes from what? Is it changes from red to blue, or blue to pale green, or yellow to pale green, or blue to purple? If you think about it, it will be blue, as the bromocymol blue exists in basic medium first, so it will be blue in color, and change it to neutral to pale green color. Next point, when adding 50 milliliter of nitric acid, its concentration is 1 molar to 50 milliliter of potassium hydroxide. Its concentration is unknown, containing drops of phenolphthalein. And at the end of titration, the solution color, it changes from what? Changes from colorless to red, blue to pale green, red to colorless, blue to purple. If you think about it, here the phenolphthalein is found first in basic medium, which has red color, and so changes to neutral medium, so it will be colorless. So the right answer here is number C, red to colorless. Next one, when adding 10 milliliter of sulfuric acid, its concentration 0.5 molar, to 10 milliliter of sodium hydroxide, its concentration is 1 molar. Then adding the solution, litmus to the solution, so the color becomes what? Red, or blue, or orange, or purple? If you think about it, yes, the answer it will be, if you think about the answer, it will be purple, as it will be neutral medium at the end. Number of moles equal. Next point, when adding 10 milliliter of nitric acid, its concentration 1 molar, to 10 milliliter of calcium hydroxide, and its concentration also is 1 molar. Then adding litmus to the solution, and so the solution color becomes what? Is it red, or blue, or orange, or purple? Number of moles of the acid and base are equal, but the base here contain 2 hydroxide ions, 2 mole of hydroxide ions, while the acid contain 1 mole of hydrogen ion. So the number of moles of hydroxide ions are greater, so make the solution will be basic, and so the color changes into blue. Next type of question, which is graph question. The following graph illustrates the mass of formed precipitate in a tube on adding sodium hydroxide solution to iron 3 chloride. As shown in the graph, the mass of the precipitate is formed at certain concentration. Illustrate on the same graph the change in the graph shape when iron 3 chloride is substituted by the following solution. Aluminium chloride solution. Here we know that the formed aluminium hydroxide precipitate will be dissolved in the excess of sodium hydroxide, forming soluble sodium meta-aluminate salt. So as the precipitate will be formed, is going to be dissolved again by adding excess of sodium hydroxide. So the answer here, if you look at the drawing here, so it will be decreased the mass of the percent in the figure as you shown. Next point, iron 2 chloride solution. Here iron 2 chloride forms precipitate also, iron 2 hydroxide, but the weight of the precipitate of iron 2 hydroxide is less than the mass of precipitate of iron 3 hydroxide. So we predict that the mass of the precipitate reach a smaller value than the mass of the first graph, as shown on the graph in the screen. Next question of graph. Which of the following graphs represent the ratios between the masses formed on adding excess sodium hydroxide to three different solutions, each one contain 1 gram of aluminium positive 3, iron positive 2, iron positive 3, and explain. If you look at this graph, my dear student, we know that the only precipitate will dissolve in excess, it will be aluminium. So we have to choose from the choices B or D. But we know that the iron 2 hydroxide has a smaller mass than iron 3 hydroxide. So the answer here will be graph B, as shown on the screen. Next point. The opposite figure expresses the change in mass of formed precipitate on adding solution of what? Two solutions contain anion of what? Then adding concentrated ammonia solution to the reaction medium. As here the graph explains that the mass of the precipitate formed is slightly soluble in ammonia solution. So what is the precipitate which will be formed with slightly soluble in ammonia solution? It will be bromide ion. So here the answer here, is it barium chloride and iodide, or silver nitrate and chloride, or barium chloride and phosphate, or silver nitrate and bromide ion? Yes, here it will be silver nitrate as forming the precipitate which is slightly soluble in the ammonia solution. Equal masses of powdered calcium carbonate were added to separate solution of hydrochloric acid. The calcium carbonate was in excess. The volume of carbon dioxide gas produced was measured at regular intervals. So if you look at the question here, which curve best represent the evolution of carbon dioxide gas against time for the acid solution shown in the table below? Here, this is the graph that formed carbon dioxide, and you have to look here the table below to choose which one will be the correct. As shown on the table, 25 milliliter of 2 molar HCl, 50 cubic centimeter of 1 molar HCl, 25 cubic centimeter of 1 molar HCl. Here, if you think about the graphs, that here the graph here 25 cubic centimeter, that multiplying 2 molar, it will be 50 moles here, and here 50 times 1 equal 50 moles also, but the third column here will be half the number of moles are formed. Here, my dear student, the cubic centimeter to change into volume by timing by 10 power negative 3, but here the column 1 and the column 2 gives the same number of moles of HCl added, while the 25, the moles is going to be decreased to half. So if you look at the graphs, here two graphs give the same volume of carbon dioxide, and one column or one graph gives the smallest number of moles of carbon dioxide, which is the third column. So the answer here will be solution. Is the answer, it will be here. If you look at the number of the moles will be added of the hydrochloric acid and each graph. So here graph 1 and 2 for the volume of carbon dioxide produced are the same, while graph number 3, the smaller volume of carbon dioxide gas produced as smaller number of moles of HCl. Next type of question. From the following experiments, deduce the salt name and its chemical formula. On adding lead to acetate solution to salt solution, white precipitate is formed. And on adding ammonia solution to the salt solution, white gelatinous precipitate is formed. Here we have to test for these two, acidic radical and basic radical. If you think about the reaction that produces here the precipitate of each one, so it will be aluminium, this is a cation, and sulfate is the anion, and so the formed compound is aluminium sulfate and has chemical formula Al2SO4O3. Next point. On adding silver nitrate solution to the salt solution, white precipitate is formed which turns violet when exposed to light. So this test for chloride ion. And on adding ammonium acetate solution to the salt solution, white precipitate is formed. So it is test for calcium ion. So here the answer of the salt here, it will be calcium chloride, and the chemical formula is CaCl2. Next point, on adding iodine solution to salt solution, it removes the brown color of the iodine. Yes, it is thiosulfate radical. And on adding hydrogen sulfide gas in the presence of dilute hydrochloric acid and the salt solution gives black precipitate soluble in hot constant nitric acid. So here the radical here is copper, and so the copper is the basic radical and the thiosulfate is the acidic radical. So the solution here is the salt, so it is copper thiosulfate solution as its chemical formula applied, CuS2O3. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today and the problems that we discussed today. So till we meet again, my best wishes for you.